Hello guys, continuing from our last video, the code that we had made earlier, in which we were able to find all the prime numbers between two given numbers. This time what we are going to do is, we are going to improve this code, optimize this code for faster output. So the previous code, this code itself does a very good job in finding all the prime numbers between given two numbers very accurately. This is absolutely fine. But now we are going to improve this code to deliver the same result faster than this code. Okay, faster than this portion of code. Okay, so what we are going to do here. So for that, to improve this code, we'll have to first understand what is a prime number. So a prime number is a number which will never get divided by any number completely without any remainder, right? So if I tell you 3 is a prime number. Why? Because it will never get divided by 2 or by any other number completely. So if you divide 3 by 2, there will be a remainder of 1, right? So hence 3 is a prime number. But this has a exclusion. So a prime number will never get divided completely by a number except 1 and itself. So 3 will still get completely divided by 1, and 3 will still get completely divided by itself, like 3 with a remainder of 0. So those are exclusions, but 3 will never get divided by any other number completely without a remainder of 0, right? So this is what the definition of prime number is. And with this definition, we know that any even number cannot ever be a prime number, because any even number will get completely divided by 2 without with a remainder of 0, right? And hence it cannot be a prime number. So that has a point for us. So that simply means between the range of this number, 35 and 65, there will be 50% prime numbers and 50% even numbers, right? How we can improve this code is, so this portion of code, this portion of these lines actually evaluate whether a number which has been passed to it is a prime or not. But we are doing that for even numbers also, whereas we already know they cannot be prime. So we can directly skip the execution of these many lines for all the even numbers. So saving time, right? So how to do that? Now let's create so once we have passed this number to this variable num1, we are going to check whether this variable is a prime number, is an odd number or an even number. How to do that? I will create a lambda function, lambda x, and what I'm saying here is, whatever this x is going to hold the number which will be passed to it. So I'm going to say x plus 1 if x mod 2 is equals to 0. That means if that number which has been passed to this lambda function is completely getting divided by 2 with a remainder of 0, that means it's a even number. So what we will do, we will add 1 to it. And if not, else we are going to return that itself, because that's a even odd number in that case. Okay. So this number, now if I pass 35 here, so this will remain 35. If I pass 34 here, this will become 35. If I pass 36 here, this will become 37. But if I pass 37 here, it will remain 37, right? So now it will always begin with a odd number and will continue the range till the end. And because but however, we still are away from our target. So let's say we started with a odd number 35, but then as soon as with this range, we are going to loop through each and every element in the range, and hence the first time this variable is going to hold 35, then it will hold 36, then 37, and then 38, and then again the even numbers will start to come in. To eliminate that thing, what we are going to suggest here in the range is the optional parameter of a step, and we are going to take a step of 2. By default it is always 1. If you do not suggest anything, it is going to be 1, and it takes a step of 1 in the range of number. But when you say 2, it takes a step of 2. So if I say range between 1 to 9, and I say step of 2, then it is going to start from 1, and then it will be 3 and not 2. So it will be 3, then it will be 5, then it will be 7, and this. So that we are doing here, right? And then once we have done that, now we know in this num it's always going to hold an odd number and never be an even number, right? So if it is going to be odd number, there is no need to divide it by a even number, right? We don't need to check whether this odd number is getting divided by a even number and the remainder is 0 or not, because we know that there has to be a remainder. So whenever you divide an odd number with an even number, there will be a remainder, right? So we already know that, so we don't need to evaluate it. So we are going to start the range from 3, and same thing, we are going to do a comma 2. So now this n will also hold all the odd numbers of this range from 3 to num, right? So this way we are going to skip a few line of codes, not a few line of codes, almost 50% line of codes in each of the loops. So for this loop, 50% of line of codes, these many line of codes will be saved for 50% of the numbers, and for this loop, this line will be, these two lines will be saved for 50% of the numbers, right? And this is the improved version of the code. But there is a challenge. Now if I run it, and if I begin with 1, there will be the very first prime number is 2, which is an odd number. And we are saying never ever pass the odd number here, and that will not be evaluated. So to prevent that, because if we want to find all the prime numbers, so if I run this, this is going to work fine. So if I run this, you see the, so what happened? Line 7 has function object cannot be interpreted. Okay, so this is a, okay. So I have not passed the value itself. So num1. So basically, this is the function lambda function, and this is the argument that I have passed onto it. So this num1 is going to get into x, evaluated, and then the result will be stored. So sorry. So right click and run, and you see the same results. But what if I make it starting from 1 to 50 and run it? It will give you correct result, but it will miss the 2. So it's giving a wrong result. So if you start from 1, you will miss the 2, because 2 is the only prime number that is even, right? So whenever you are doing this step, you will have to ensure that you at the very beginning print 2 as the result, because you have anyways skipped all the odd even numbers. But 2 is also an even number and also is a prime number, so we cannot skip that. So now if I, so hence I have, in the very beginning I have printed it. So now if I run it, see, starting from 2, if all the prime numbers between the range of 1 to 50. So this is how this code will get improved and give you a faster output. Okay, so in the next video probably I'll create a timeit module, and I will show you both the running both the functions through the timeit module, and show you how this improved method will take less time than the previous one. So thank you so much guys for watching this video. I will add more small videos for break, for else, range, and lambda here in this playlist. Do watch them if you want to learn them. And I will also run a timeit module video. Create a timeit module, run it, and create a video for that, showing you how this code delivers you a better, faster output. Okay, and for the coders, any coder if come across any challenge that they are facing in while coding something in Python, do write me an email over my email ID stupidbutcurious@yahoo.com, and I will try to help you. Give me a like if you like this playlist for prime numbers, and subscribe to my channels for more such videos. Thank you so much guys. Thank you. Bye. Have a nice day.